This video will teach you how to do polar coordinates. In particular, we're going to look at how to graph in polar coordinates, and then how to change back and forth between polar and rectangular coordinates. The graphing that we've done previously has always been in the rectangular coordinate system. The rectangular coordinate system is based on the horizontal and vertical distance from the origin, and that's how we locate the points using the system. It's the points x, y. In the polar system, we're going to do it a little differently. For the polar graphing system, it's a system represented by the location of the point given two values. The first value is going to be called the directed distance, r. That is the distance directly from the origin to the point. We'll call that the radius. That's what we use the letter r. Now the next value we're going to use is theta, and that's the directed angle. And that is the angle that is between the polar axis and the segment that connects the point to the origin. Let's look at a picture of what I mean by this. Here we have some point. The directed distance is the distance that is directly from the origin to the point. So that's going to be our r value. And then from the polar axis, rotating up to that segment that connects the origin to the point, that is going to be the directed angle. We'll plot these points using both the r and the theta. So in the polar system, we'll use coordinates r, theta. Now keep in mind that for positive angles, those are going to be counterclockwise direction, just like everything else we've always done. Counterclockwise will be a positive angle. All right, so let's look at some examples on how to plot these. Here I've got 4 points, and we're going to go through on how to plot these. Keep in mind the first part of the coordinate is the radius, and the second part's the angle. So when you have, for number 1, the coordinate 4, 5 pi over 3, we're going to start by finding where the fourth radius is. So if you look at our circles, we have these concentric circles here, we're going to go out to the fourth circle. That'd be this one here. This represents everywhere where the radius is 4 units. We're now going to find the angle that's 5 pi over 3. 5 pi over 3 is down in the fourth quadrant, and we're going to find where it intersects that fourth circle, and we'll mark that as the point. So on that red circle, where it hits the 5 pi over 3 is going to be this point. So this point is the coordinate 4, 5 pi over 3. Now in radians, you can actually name angles, or name points rather, in different ways. Another way to name this would be, instead of using a positive angle of revolution, we could have used a negative. So this point could also be called 4, negative pi over 3. If we rotated a negative pi over 3, that would take us to the same angle, and we're still in the fourth circle. So there's multiple ways to name these. All right, let's look at another example. For example 2, we're going to plot the point 3, negative 7 pi over 6. So we're going to go out to the third circle, but instead of rotating 7 pi over 6 in a counterclockwise direction, we're going to go 7 pi over 6 in a clockwise direction. That's going to take us to right here. Again, we rotated negative 7 pi over 6, so that's just past pi, but going in the other direction. Now, there are other ways to name this. We could have named it, instead of 3, negative 7 pi over 6, we could have named it with a positive angle of revolution, in which case this would be at 5 pi over 6, so another name for this would be 3, 5 pi over 6. Again, there's multiple names for that same point. Let's turn our attention to number 3. Here we have a negative radius. Now the negative radius means we're going to use that second circle still, but we're going to go in the opposite direction. So let's take a look at how this works. To plot negative 2, 7 pi over 4, we'll start by finding the second circle. We'll go to where 7 pi over 4 is, but instead of moving in this direction, we're going to move in the opposite direction. So we're going to go this way instead. And then where it intersects on that radius of 2, that's going to be our coordinate. So this point right here would be negative 2, 7 pi over 4. Now there's multiple ways to name this. Instead of using the negative radius, we could have used the positive radius and said that this was going to be 2, negative 7 pi over 4. Or we could have used all positives and said it's really 2, 3 pi over 4. Again, there's multiple ways to do these. All right, let's look at one more example here. Let's plot the point negative 5, negative 5 pi over 4. Let's start by finding where the fifth radius is. And then we're going to go to where negative 5 pi over 4 is. That would be this angle right here. But we're going to go in the opposite direction because we have a negative 5 length. We'll go this way. And where this segment now intersects that fifth circle, that's going to be our coordinate. Now there are other ways to name this. We could have used all positives and said that this is a positive 5 radius, and the angle positively would be 7 pi over 4. So we could have called it 5, 7 pi over 4. Or we could have used the -5 length and then the positive 3 pi over 4 angle. That would have meant we went to 3 pi over 4, but went the opposite direction. So again, multiple ways to do this. All right, now let's look at some examples of how to convert. All right, to convert a polar coordinate into a rectangular coordinate, we're going to need some trig definitions. And the ones we're going to use are for sine and cosine. Keep in mind that cosine theta is x over r, and sine of theta is y over r. Now, solving for x and y, we would get x equals r cosine theta, and y equals r sine theta. Now, if we're given the radius and the angle in polar coordinates, it's going to be real quick to be able to just convert these to x and y using the sine and cosines. So let's look at a couple examples. We're going to convert 5, 2 pi over 3 and 4, 3 pi over 2 to the rectangular coordinate system. All right, so let's do an example number 1 here. Here the radius is 5 and the angle is 2 pi over 3. So to start, let's find x. And keep in mind that this coordinate is going to be in the second quadrant. It has a 2 pi over 3 angle, which is going to be in quadrant 2, and a positive radius, which means we go in that direction. So I expect that in this case, x is going to be negative and y is going to be positive. So as I do this, I want to make sure I'm getting these kind of answers. All right, so if x equals r cosine theta, let's plug it in. Here, x equals 5 cosine 2 pi over 3, and the cosine of 2 pi over 3 is going to be negative 1/2 using our unit circle, and we get 5 times negative 1/2, which is going to be negative 5/2. So there's x. For the y value, we're going to go r sine theta. At 2 pi over 3, the sine is going to be root 3 over 2. So we'll get 5 times root 3 over 2, which becomes 5 root 3 over 2. So the coordinate xy is going to be negative 5/2, comma, 5 root 3 over 2. Why don't you go and try example number 2, pause the video and work it out. When you're ready, resume the video to check your answers. I'll give you a moment. All right, hopefully you had a chance to work this one. All right, using x equals r cosine theta, and then we're keeping in mind that this coordinate is straight down on the y-axis, I expect it's going to be 0, comma something. All right, here we go. X equals r cosine theta, substituted in becomes 4 cosine 3 pi over 2. The cosine of 3 pi over 2 is going to be 0, and 4 times 0 is 0. R sine theta is going to become 4 sine 3 pi over 2. The sine of 3 pi over 2 is negative 1, and 4 times negative 1 is negative 4. So like I thought, this is going to be 0, comma, negative 4. Now let's look at two examples where we're going to go the other way. Let's start with a rectangular coordinate and move it into a polar coordinate system. Here, we're going to need some different definitions for trig. Instead, now we're going to use that tangent is y over x, and that r equals the square root of x squared plus y squared. Now we're going to want to use the tangent instead of sine or cosine, because then we don't need to find the radius initially, we can just use the y and x. We'll use the radius later on by finding the square root of x squared plus y squared. Now you could have used sine and cosine, it's just going to be more work. So instead, let's just use tangent. All right, here we go. Two examples. The first one, we're going to plot the point 5, negative 3. Now 5, negative 3 is over in quadrant 4. I'm going to take tangent, and I'm going to say tangent of theta is y over x, which means tangent theta is negative 3 over 5. I'll take the inverse tangent to find theta prime, and here's where it gets a little bit more difficult. When I use my calculator, it's not going to give me the angle in quadrant 4. It's going to give me my reference angle. So the inverse tangent of positive 3/5 is the reference angle, which means that's 0.54. Now 0.54 cannot be in quadrant 4. Quadrant 4, you're more than 3 pi over 2, but less than 2 pi, and that's not going to be 0.54. 0.54 would be in quadrant 1. So keeping in mind your adjustments, we're short of 2 pi, so to find theta, we're going to go 2 pi minus that reference angle. 2 pi minus the 0.54 is going to be about 5.74. So there's theta, and now let's find the r. R is going to be the square root of x squared plus y squared, which when we substitute it in is going to be the square root of 5 squared plus the quantity negative 3 squared, which is the square root of 25 plus 9, which is going to be root 34. Now we don't need to simplify it, we can just call it root 34. So it's going to be the coordinate root 34, comma, 5.74. That's r theta. Why don't you go and try the second example, pause the video and again work it out, and then resume the video to check your answers. Again, I'll give you a moment. All right, hopefully you've had a chance to do this. All right, now negative 2,7 is in quadrant 2. So I expect that my angle is going to be between pi over 2 and pi. So when I do my correction, I'm going to have to go pi minus the reference angle to find theta. All right, so let's try this. Tangent is going to be y over x, which in this case is 7 over negative 2. Inverse tangent of positive 7/2 is going to be theta prime. And that's going to be about 1.29. Now to find actual theta, we're short of pi. So we're going to go pi minus the reference angle, in which case pi minus 1.29 is about 1.85. So there's theta, and now let's find the radius. R equals the square root of x squared plus y squared, which in this case is the square root of negative 2 squared plus 7 squared, which is going to be root 53. So the coordinate in r theta is going to be root 53, comma, 1.85. All right, so let's see how this works out for you today. Go ahead and try the assignments posted, and let's see how it works out.